Hello students, in this session we are going to see about programmable logic controller, which is the fourth unit in mechatronics. First, the syllabus in PLC are introduction, the basic structure, input and output processing, programming, mnemonics, timers, counters and internal relays, data handling and selection of PLC. The contents in PLC includes the basic structure, programming, mnemonics, timers, counters and internal relays, selection of PLC. These are the contents which we are going to see in PLC. PLC or programmable logic controller is a digital computer used for automation of typically industrial electromechanical process such as control of machinery on factory assembly lines, amusement rides or light fixtures. The applications of PLC are automated manufacturing process equipment and machinery, packaging and filling equipments for chemical mixing, conveyor system and distillation, etc. The features and specifications of PLC include: they are rugged and designed to withstand vibration, temperature, humidity and noise. The interfacing for input and output is inside the controller. They are easily programmed and have an easily understood programming language. Programming is primarily concerned with logic and switching operation. PLC is designed as the replacement for hardware relay and timer logic, where PLC provides us ease and flexibility of control-based programming and executive logic instructions. The internal functions such as timers, counters and shift registers make sophisticated control possible using even the smallest PLC. PLC is capable for performing counting, logistics, numerical applications, comparing and processing of signals. PLC is divided into 4 parts: input-output module, central processing unit CPU, memory and programming unit. Input-output module. It is used to transfer the data between external devices and CPU. It is incorporated into the PLC in 2 ways. 1. Fixed input-output. It is a small unit that comes in with one piece with processor. That is, the input-output terminals cannot be changed in fixed input-output. Modular input-output. It is packed together, that is, there are several compartments of input-output module which are plugged together. So this is the difference between fixed and modular input-output. Central processing unit. It consists of microprocessor which interrupts the input signal and carries the control actions according to the program stored in the memory, communicating the decision as the action signal to the output. The CPU can scan the total information package stored in the memory and input and output devices continuously. During the scanning, the CPU executes instruction based on input data and sends appropriate output response to the output devices. The updates data acquisition system and indicate condition changes. The CPU can scan time for larger unit depends on the size of the memory and configuration of the system. The power supply unit is needed to convert AC voltage to low DC voltage, which is necessary for the processor to supply the power and other circuits in the input and output interface module. Memory unit. Memory unit in PLC stores the digital control logic, the process program and necessary instruction to operate the system. The memory used in PLC are non-volatile memory, volatile memory. According to the purpose of usage, RAM and ROM are also used, which is volatile and permanent storage. Programming unit. It is used to enter the required program into the memory of the processor. There are normally 3 approaches followed by the program. First, use the handheld programmer. Next, terminal with video display unit. Third is the PC with appropriate software. Buses. We have address bus, data bus, control bus and system buses. Data bus is used for communicating data between elements. Address bus is used to read the address of locations for accessing storage data. Control bus is used for internal control action carried by the CPU, and system buses is used for communication between input-output port and input-output unit. Memory is RAM, ROM, and ROM has PROM, EPROM, programmable read-only memory, erasable programmable read-only memory, and electrically EPROM, electrically erasable program read-only memory. Optoisolator. Electrical connection from the external world is usually by means of optoisolator. When the digital pulses passes through the LED, a pulse of infrared radiation is produced. This pulse is detected by phototransistor and gives rise to the voltage in the circuit. Common input voltage is 5 volt and 24 volt, and the output voltage is 24 volt and 240 volt. Output are often specified by relay type, transistor type, or triac type. Programming of PLC is based on the ladder diagram. The ladder diagram involves writing a program in a similar manner to drawing a switching circuit. This is the ladder diagram for a timer in which input and timer and output is taken. Delay on timers. The term delay is used to indicate that this timer burns on after waiting for a fixed time of delay period. When there is an input, the timer is energized and starts timing. After some preset value, the timer contacts and closes the output. T on is used to denote on relay. Delay of timers. Off delay timers are maintained as on for the fixed time of delay period before turning off. T off is used to denote off delay. Timer circuit program to cause an output for go on for 0.5 seconds, then off for 0.5 seconds, then off for 0.5 seconds, and so on. So this is a ladder diagram giving an input and the timer 2 with timer 1, and timer 1 when it is open, the timer 2 output is taken, and timer 2 output is given, and the output is taken on off cycle timer. Counters. Counters are used to count a specified number of contract operation. Types of counters: up counters, down counters. Up counters. Up counters count up from 0 to preset value. The events are added until the preset value is reached. When the counter reaches the set value, it contacts change state. Down counters. Down counters count from preset value to 0. The events are subtracted until the preset value is reached. When the counter reaches the 0 value, it contacts change state. Data handling. Data movement, data comparison, arithmetic operation, and code conversion are the methods used in data handling. The data comparison instruction given to the PLC compares the two data values, and the preset value is 1 and the input value is 2. Instruction less than or equal, greater than, less than or equal, not equal. For data comparison, the typical instruction will remain constant. The data transfer instruction to compare the data from source address and destination address as shown in the diagram. The code conversions. All the internal operations in the CPU of the PLC are carried out through binary numbers. Most PLC provide BCD to binary and binary to BCD conversion for use. When a decimal signal is given, BCD conversion is used. Similarly, when a decimal output is required, decimal conversion is used. The data at the source address is in the BCD and converted to binary and placed at the destination address. The BIN S and D is a source destination which changes to BCD S and D. Controlling the speed of the motor, we have a control module with 24 watt supply and DAC module, digital to analog converter, and a driver and the motor, which is shown in the ladder diagram. Thank you.